going to start by saying that this is a talk about automation and workflows in small startups in regards to not having 100,000 developers. We're in the other end of the spectrum. So we're somewhere between 2 and 4. So let's see. I will start with a disclaimer, because this is not going to be a talk about best practices. I believe that best practices is something that is very context sensitive, and it depends very much on the situation you have in front of you. What it is going to be is a talk about the things that we found that works well for us. So it's a talk about the automations and the things that we've done that we found that works well. And one of the first thing to notice is that I also had an alternative title saying how TDD and automation helps us scale. So you'll notice that I will actually talk a bit about TDD in this talk as well. And if I seem a bit nervous, bear with me. First talk in 2 years, there was some kind of thing happening in between the last conference and now, some kind of pandemic. So I will start with a quick introduction of myself. My name is Eric, and I'm the software architect, co-founder, and current CTO of PayZlip, a small startup located here in Helsingborg. And I'm a long-time TDD fanatic. So I will, as I just said, I will talk a bit about that. You will notice what I mean. I have a background in mainly let's call it non-managed languages. So C, C++, mainly C++. Done a lot of rendering and stuff like that over the last couple of decades. So lots of D3D, OpenGL, and so on. Some console programming, etc. Last 10 or so years, I went more into managed languages, so a lot more C#, a lot more Java, and so on. And then from there, I ended up in a lot more web and application programming in general. So today it's a lot of TypeScript, JavaScript, and so on. Except PayZlip, I also make games. So I make digital games, and this is the nice physical things that our publishers put out. There's a reason I have this one. It's not just to show off. It's also to kind of talk about where my interest in automations kind of started getting real. So when we started doing games, me and a couple of other persons, incidentally some of the same ones who are involved in PayZlip, we kind of had to go beyond automated testing and build servers. We also we were too small to kind of not be able to deploy automatically. And we ended up having something where we said, okay, for Steam, for instance, whenever we want to publish a new build, wouldn't it be nice if we could just merge to master, give it a few minutes, and then pick up a controller and just play the game? And especially with Steam and GOG, that's very much what we ended up doing. So we ended up building a lot of processes in order to make that happen and be able to trust that deployment as well. And a lot of this carries over to PayZlip in a few different ways. One of the major ones being, of course, that we have an application on a phone. So we have deployments to Google Play, we have deployments to the Apple Store, and on top of that, we also have all kinds of deployments to AWS. So we have a bunch of blue-green deployments on various services, applications, and APIs. So PayZlip is a company that is all about automation, which is kind of nice because what we're doing is automating the entire flow from time reporting from a employee perspective to actually paying salaries on a employer perspective. As I said, we don't have 100,000 developers. We have 2 developers in the core team, maybe 4 developers sometimes. So we're a very small team. It's a CQRS and event source system, kind of a lot of moving parts in it, some added complexity due to that. And we need to make sure that we spend time on the right things. So I'm just going to show you real quick what the app looks like and talk a bit about our architecture. So let's see if we can get someone to hit play on this one. So this is what most employees will see. This will simply interact with the app and not really see the rest of the system. Of course, this is just part of it. There's a lot more going on. So, but from the view of an employee, it's in basically an app that you're using. And this is the time reporting part of it. Now, let's see if I can switch slides. So, talking about the architecture, though, there's actually quite a lot happening more than just that one, because we have the employer side of it as well. We have a bunch of Redux applications, React Redux applications, and some internal tooling as well. So in short, what our application looks like, or our architecture, is that we have a gateway API. This is just your standard REST API. There's nothing weird about it. It's post, put, get, delete, and so on. And whenever we get something in here, so that actually mutates, like say, post, put, delete, patch, whatever it might be, that is interpreted as a command. So it needs to be validated, it needs to be authenticated, and so on, and we make sure that everything is all right. And if it passes all our validation, then we generate an event. So we have an event store where we simply push those events. This is an event store DB. And after that, we have services who simply subscribe to these events. And these services there's no inter-service communication at all, because if they need some data from another service, we just listen to the events. We have all the events, so we just reinflate our events, our read sites, and just listen to all the events again. So as soon as an event hits a handler, we just record the position of that stream and build up our read model. And on the other side of this API, we have our clients. So we have the Android and the iOS apps that I just mentioned. We have the administrator web application, which is kind of where you handle things such as salary, time reports, and so on from an administrator perspective. And then we have another portal as well, where you kind of set up your company and so on. So there's quite a lot of release management around this as well, especially for two people working on the code. And we have a bunch of API services, front ends, and so on that we need to deploy in some kind of reasonable way. We have apps that need to be automated and uploaded to Google Play Store and the Apple Store. We are using Fastlane in that aspect and some own scripting on top of that. And of course, handling all of this infrastructure, which we use CDK for. So we pretty much type our infrastructure as code all the time. So automation for me is there we go. The first part of automation for me, this is not the only part, but one of the major things is spending less wall clock time on things that could be done by machines. I don't really care about the time aspect as such. I care about freeing up time for me. I mean, it might actually take me 10 minutes to do a manual deploy, but I don't really want to do that. I don't care if it takes my build server 10 minutes, because it's probably cheaper than your time, hopefully. Otherwise, you're either underpaid or have a very expensive build server. But it's also about having a reproducible workflow. So it's not just about making things fast. There's also the error proneness of things. So you might want to actually have something be automated in order to make sure that the same thing happens every time. So the things we have to ask ourselves is, will the task that we have take enough time and be done frequent enough to be worth automating? This is the obvious point. And of course, you have to ask yourself this. But it's also worth asking yourself if it will add a level of stability to the point where it would tip the scales in favor of automating something anyway. So just as an example, and this is a fairly basic thing that we notice very quickly that we should probably automate, and that's screenshots on the app stores. So we have 4 screenshots, and it's the same one for Android and iOS. On the App Store for iOS, we have 4 screenshots on 4 different devices. So that's the minimum we can have, which is just different tablet sizes, phones, and so on. We also have 4 screenshots in Google Play for 3 different devices. So for the 4 same screenshots, that's actually going to build up quite a lot of versions of the same screenshot because it needs to be done on different sites, screens, and so on. It's also a localized app. And currently, it's localized in Swedish and English. So that kind of doubles the amount of screenshots. And if we crunch the numbers, we notice that this alone is 56 screenshots. So let's say that I want to add a 5th screenshot to the store. In that case, I actually have 14 new variants of that screenshot. And let's say that I add another language. Well, then you can multiply by 3 instead of 2. So it builds up pretty fast. And this is one of the things that we just noticed fairly quick, that we can automate this. Could we play this in full screen if possible? Let's see. So what we did was basically, sorry if the screen is a bit hard to see. Hopefully it's kind of readable. What we did was basically write a shell script that just uses Android debug bridge in this case. We have a very similar one for iOS. It simply starts up our environments, our machines, and runs a series of tests, in this case, just integration tests, more or less, interaction tests, whatever you might want to call it, with using a driver, basically a Selenium-like driver. This is written in Flutter and Dart, by the way. So one of the nice things here is that we have a reproducible workflow where it simply runs our process for all the devices we've listed in a shell script. And we wrote that shell script in, I don't know, maybe 2 hours or so. So yeah, we can't do extremely fancy stuff, but we have all the screenshots in all the languages, and we can even automate so it ends up in the right space, and then we just upload everything using Fastlane to the App Store. So let's see here. I think you need to, let's see. Okay, so this is what a test looks like. This is a widget test. I hope it's readable. I would have picked a lighter background had I known the contrast in here. But it's basically a widget test. And we're just interacting with the app in the way we want to, and then converting it to an image, making sure there's no events in the events pump, and then just screenshotting it. And we have the same tests for all of our platforms. Both iOS and Android use one set of tests. And we do this for all languages. So it's actually quite a simple thing to do once you have the setup. So it's quite a bit of setup, but once it's there, it's easy. And this was just kind of show you what the kind of things we are automating. In reality, what I want to talk today is 3 different principles to allow you to automate things. And I want to talk about automated testing, including TDD. They're not necessarily the same thing. I want to talk about CI and CD, and I want to mention briefly convention over configuration. So first of all, when it comes to TDD, it's something that enables automations for us. Who in here does TDD, by the way? Quite a lot more than I noticed. I'm actually very happy to see that. More than I expected. I'm happy to see that. And in that case, you also know that TDD is not automated testing. There's quite a bit of difference there, but TDD basically implies automated testing. But automated testing is, TDD is more than just automated testing. It's something that actually drives something as well, right? It's test-driven. So for instance, in our case, this would be a very simple parser for our tax table parser. So what we're doing is just parsing the JSON format from Skatteverket in order to get tax data out, in order to understand what kind of tax we should deduct from payments and so on. And in this case, this is just a very simple stub, and table number would be the tax table number. Most people are in the range 30 to 32-ish somewhere, and the year would simply be the tax table year. So what we end up doing is, of course, just writing our tests. making sure that we have some kind of reasonable description, doing tests first. We feed some JSON in this case that we have a local copy of on of the tax tables, and just basically a subset to represent the format. We read that in, we do our assertions and expect the year to be 2021 and the table number to be 32 because those were the numbers we had locally. We run our tests, make sure that we have a failing test. You always want to make sure you have a failing test. And we take a look at our code again and just implement it. So this is something we do in all our services, and for a very good reason. And especially the whole red-green refactor thing where you actually see the test fail. So this is one of our services, a subset of one of our services. But we also have our Flutter apps. We have some 200 tests in that one. We have our React Redux where we have some 210 tests. We have something similar in our portal. And then we have our gateway API where we have a mix of unit and end-to-end testing, mostly end-to-end testing to be fair, where we test everything from status codes and responses and so on as well. And you can, I don't know if you can see it, but this one says 58 seconds, which is pretty much how you can tell that these are end-to-end and not unit, because the other ones took 2 seconds. So there's quite a bit of time difference. And as I said, TDD is not really automated testing, it's more than that. Something that implies test-first development because it's test-driven. And test-driven development implies letting your test initially fail. I've seen a lot of people who do test-driven development by adding the test and the implementation at once and never seeing it fail. And you're missing a dimension of the value that you can get out if you're not doing that, if you're not seeing it fail. I've had tests not fail, only to notice that I forgot to write an assertion. That's one of the more stupider things I could probably do, but there are definitely more subtle cases where tests pass. You should probably always be a bit suspicious if your tests pass right away. And of course, a failing test needs an implementation. So this is for you, those of you who probably aren't all that familiar with TDD. I just want to give a quick primer. We have the red-green refactor cycle, where red simply means that we are having a failing test. Green means that we're implementing it, and then we have a refactor part. And this is something I didn't understand when I first started doing TDD a bunch of years ago. That the refactor part is the big thing. That is the one important thing that we can get out of this. And I don't mean as in refactoring every cycle as you type your tests. I mean that when you have maybe 200, 300, 500 tests, maybe 1,000 tests, that's where you start seeing real value. That's where you actually start noticing that when you refactor, oh, now I have 200 tests not passing. Now I have a checklist of what to actually do. It's of course not 100% fail-safe, but it's still something that you kind of can use as a template. And if you find some weird bug after that, guess what you do? You write a test and reproduce the bug. So why am I prattling on about TDD in an automation talk? And well, first of all, TDD is something I've noticed that it tends to not be on the top priority of people's lists because it's hard. It takes a lot of, and I'm sure that people have noticed it. It takes a lot of effort to get it right, and you have to allow yourself to be a worse programmer for a while when you're just getting into it, because you won't be as fast as you used to be until you actually get the flow of it. And the problem is that you're not seeing the value when you're starting out with just things such as TDD katas or whatever it might be that people throw your way when you're learning it. That's not where you see the value. You see the value when you're north of 500 tests. That's when you're starting to really be able to appreciate what's going on, or when you have that one weird bug and you can write a unit test and actually reproduce it. So why I am talking about this is because this very much enables us to do CI. It's basically what drives us to be able to do good CI. It's something that allows us to have a working pipeline. So this is one of our GitHub action files. It doesn't really matter which one because they all almost look the same, which is something I will get to soon. But when it comes to the build pipeline, we do this for all of our branches, all of our commits. We always build and run tests and run the linter, the prettier, and build the app and so on. We don't only do it on pull requests or on anything like that. We always do it. And when it comes to release, what we do actually focus on doing on branches is deployments. So one of the things we notice is that not having a development branch helps us. Just focusing on the master branch and keeping it as close as possible to that one. So we always deploy to the test environment whenever we have a merge to master or a push to master. That's always, it just goes live in the test environment. If it's a tag, it also goes live on the test environment. So those two always just deploy to test. And then we also have a production deployment. And the production deployment only deploys when it's a tag. But basically what it means is that we are releasing on tags. We don't have release branches. We don't have, and I'm not saying release branches are bad. I'm just saying that we haven't had to use them yet because we are focused on releasing as often as possible from master. So pushing to production happens in some part of the system daily. It happens most of the time, many times a day in some services, and going from test to production should be quick. So we want to kind of merge something, wait for it to go live in test, give it a test, see how it works, make sure that everything is okay, all migrations ran, and so on. And once everything is greenlit, then we just merge it, well, tag it and push it to production right away. So it's usually, we try to keep it to a matter of minutes or maybe hours. And as part of this, one of the things that is extremely helpful is feature toggling. Does anyone in here use feature toggles in their code? So feature toggles should, for the most part, be fairly short-lived, but we are using something called Growth Book. And so can we play this video? And this is a, you have the app on the right here. We have our feature toggles on the left. There's all kinds of different services that you can use for feature toggling. But the idea is that we just toggle a service on and off. And we can do this independently on test and the production environments. So this also allows us to do things such as A/B testing, for instance, setting up that 50% of the users should get this feature, 50 should get this feature, and so on. Or just whitelisting certain features for certain users, whatever it might be. And it allows us to even push things that aren't ready out into production and just turn it off and hide it behind a toggle. Because sometimes we need to push API updates and we don't have a client that could use that endpoint right now, and we just turn it off. Let's see if I can. So our entire deployment kind of looks like this. So let's say we're on the master branch, we're working here, we create our branch, we use feature branches, and we do something called trunk-based development, basically keeping as close to master as possible, as mentioned before. We always use a convention where we have the name / and then our feature name. And if you know Git, you also know that this creates nice little folders in your .git folder. Anyway, why we do this is basically because you own that branch. So if your branch starts with your name, don't have any expectations if it's not your branch. Don't base your work on it without at least talking to the person who have it, because you have the right to force push, you have the right to do whatever you want on this branch or merge commits or whatever. Once the feature is done, you open a pull request. If all our checks pass, then we start reviewing the PR. So we don't really care about reviewing too much unless we see that, well, everything passes. Because before then, it's usually small stuff, but like a linter error or something like that. But we usually don't care about looking at the actual code until we see that all the other checks pass. Once a feature is done, we merge it to our master branch. And this is where it goes live on the test environment. We then tag it using a kind of semantic versioning. So what we do is simply use a major and a minor patch number. So in this case, we would tag it with 0.1, for instance. And then we use git describe to actually calculate the patch version. So we notice that it's just major and minor. We don't have the patch version here because we can automate that. So whenever we continue working, git describe simply gives you the number of commits since your last tag. So this would be version 0.1.0, this would be 0.1.1, next commit would be 0.1.2, and so on. And as soon as we have something that we want to get out into release, we just tag that one, and then you have 0 commits from the git describe since your last annotated tag, and we're back at 0.2.0. So one of the things that we've noticed helps a lot, because there are a lot of branching models, and it's just keeping it as simple as you can get away with. This was pretty much the simplest thing we could get away with, short of just pushing directly to master, but we kind of want to have code review before we do that. So, but that combined with feature toggles allow for very frequent releases. So one of the last things I want to discuss is convention over configuration and how that has helped us. So convention over configuration is just the idea that instead of making things malleable and configurable in as many ways as possible, we just want to kind of follow the same conventions and make sure that people know those conventions, because that is something that allows us to reduce the number of decisions that we need to take on a daily basis. It's also something that allows for homogeneous code bases, and this is something that not everyone likes, but I am personally very happy with it. I've heard things such as, oh, if you do microservices, you can use any language you want in any kind of technology. It's just that having that mindset that you have to switch from, oh, right, now I'm in a Go service, and now I'm in a TypeScript service, or SJS, or whatever. That mental context switching is actually very, very expensive. So just keeping all our code bases homogeneous is worth a lot. So all our services look the same. They have the same NPM targets. They have the same database setup. Everything is the same. So if you go from one service to another, you know exactly what to do, because this even helps with onboarding. So we have one workflow. We release using the tag system in the same way, regardless if this is the mobile apps, if it's the front ends, or if it's the services. And of course, the services can look very similar because they are very similar. And the other things, such as front ends and so on, of course, differ where they have to, because it's a different technology in some sense. But just keeping at least not homogeneous, but as close to homogeneous code bases as possible, having them look as close to each other as possible helps a lot. So, as I said, all our services have the same conventions. Pulling CloudWatch logs or logging into instances running at Fargate. We have the same NPM targets. We can just write npm run AWS :logs, for instance, in one of our services, and it will always work. Things such as naming conventions come into play here as well, because we actually have a seed repository where we generate our services. So together with CDK, we can have a new service up and running in, I don't know, 20 minutes maybe, something like that. And I figured I will just take a really quick look at what this looks like. So I will head down to my computer down here and see if I can show you what our NPM targets look like. So right now I'm in our API, and I can just do an npm run AWS logs, and I will get all the logs from all the running instances of this specific repository. So in this case, our API. And if I do the same thing, this is one of our services, I can just do the exactly same thing. I will get that log. If I need to go into production mode, I can simply use a different AWS profile and just do this instead. And then I get production logs. And this works in all of our repositories, so it's not just one or a few of them. And that's specific form of writing our code as closely as possible to each other in the different repositories has been very helpful. Let's see if we can get the presentation back. There we go. And one of the things that I would love to talk more about, and feel free to ask me questions about it later, because this is something that has been very useful to us, is the idea of infrastructure as code. So we use CDK to deploy all of our stuff, basically, and to make sure that our production and our test environments don't differ. We use those to keep those in check, basically. And we have the exact same setup on both of them. With I think the only exception is that we don't quite care about backups as much in the test environment, of course, but other than that, they are identical. However, I think I'm fairly out of time, so I will actually have to leave this one and take questions on the panel afterwards instead. And before I quit, I just need to go through a few key takeaways I feel, and saying that if you don't do TDD already, consider it. It will give you great value. If you've looked at it and said, no, this seems like a harder way to write code, consider it again, give it a chance. It will give you value, I promise. Because tests give you the confidence to automate things. Feature toggling helps you release often and keep your branching model simple, and just consider same conventions rather than configurable instances where you have a malleability you might not even need. So before I end, I will just add a shameless plug and say if you're actually looking for something like this and think this is interesting, we're hiring. Other than that, thank you.